This is the review for the factoring test. So let's get started. The first 5 questions are formatted to look like questions you might see on the computer-based state test, which is taken your junior year. So that's why there's a different format on some of these. But it's basically asking the same question. So let's get started. So go ahead and factor this trinomial and see which are on that list. So we're going to check every box here, which is important. We got to put a check in either one, factor or not a factor. And we know that, doing this for a while, that there are probably going to be 2 that are factors and the rest that are not. So what 2 numbers multiply to 24 and add to 14? Right? And you'll end up with 12x and 2x. 12 times 2 is 24, 12 plus 2 is 14. So once you do all the work, it'll come out to x plus 12, x plus 2, which means we'll put a check into those 2. Those are factors. And then by default, the rest are not factors. And that's all. So even though there's a lot of words in a big table, if you see something that can be factored, just do that first and you'll kind of see, like, those are going to be on the list. Okay. Number 2 is very similar. Determine if it's factorable or prime. So we're looking at each one of these. Okay, so x squared plus 25. If this was a minus, it would be factorable, but since it's a sum, because remember we have those things called difference of squares, where we have 2 different squares, x squared and 5 squared, but this has to be a subtraction, a difference. This is addition, right? So that's going to be prime. I'm not going to be able to do that. And there is no GCF. Right. So here, 4x plus 4y, you can easily see there's a 4, a factor of 4 in each one. So that's factorable. We can take out a 4. The GCF does count as factoring. Here's a trinomial, so you can see what multiplies, if anything, multiplies to negative 7x squared and also adds to negative 7x. Right? So what multiplies to the first and the last, but adds to the middle. And you will not be able to find any numbers that multiply to 7 but also add to 7, the same 2 numbers. That's going to be prime. So if you can't find the numbers here, then that will mean it's prime and there's no GCF. The last one, you can easily see that, well, there's a factor of 2 in each one of those. So you can take out a 2, and there's something left over in the middle. We really don't care because as soon as we took out a 2, it's factorable. We factored out a 2. We really don't care what the final answer is, so there's no need to keep on going. Okay, so that will finish that one up. Let's go back over here up to 3. Okay, mentioned difference of squares before, so can we write this as 2 squares being subtracted? So this is going to be n squared minus 8 squared. Right, it has to have both, so we got the square, right, and it has to have the difference. It has to be subtraction. So as long as it has a difference of 2 squares, then yes. Here we have a difference, right? It's minus, but 50 I can't write as something squared. So since 50 is not a perfect square, that's going to be no. Here I have 2n to the second power. That's what 4n to the second is. And 100 is 10 squared. So this is a difference, subtraction, of 2 squares. So that's going to be yes. And lastly here, this is very close, but we have minus 3 squared. But this first term, you can see there's no square here. So we cannot write that first term as a squared. Okay, so we can't do 3 into the second would not work because that would mean this would have to be n to the second. So that's not a difference of squares. It's factorable, right? We're not asking that, but it is not a difference of squares, perfect squares. Okay, lastly here, let's see here. Rectangle has an area of this, and through factoring, so basically we're using the idea of our answer being like a base times height. So like I said before, number 1, if you see something like this, and you can see the answers. It's a good hint that you just need to factor it. So there's no GCF here. So what two numbers multiply to negative 40b squared and add to 6b? Right, and we'll come up with, looks like probably a 10 and a 4b, with the 4 being negative because 10 minus 4 is 6. Okay, so we'll get a b plus 10 and a b minus 4. And just see which ones are on that list. So you can see b minus 4 is here, and b plus 10 is right here. So there could be 2, there could be 1. Make sure you circle both. All right, going down to number 5. Once again, what is a factor here? So go ahead and factor it. If you try to do the x right away, you'll notice it will not work. Okay, so first thing, the step 1 is always a GCF. So you'll notice there's a factor of 2 in each of these, and there was also a factor of n in all of those. So we're going to take out a factor of 2n, which means down here, 2n is a factor. I took it out. All right, so left over is n squared minus 12n plus 35. Right? And then go ahead and factor that further and see if any of those are on that list. So what two numbers multiply to 35n squared, right? First times last, but add to 12n. And you'll end up with probably negative 7n and negative 5n. That multiplies the positive 35 and adds the negative 12. So we'll have minus 7 and minus 5. Okay, so it looks like minus 5, and it looks like all these others are not factors. All right, go down to the back page, which is just the straight factoring. Now there's some directions here, so use them as hints. The first part says factor out a common factor only. So it's kind of giving you a hint. All you need to do is GCFs on here. That's where we started, just finding GCFs, nothing else. So what goes into 28, 32, and 40? What's the biggest number? Probably come out with 4, right? And there's also a V in each one of these, so I'm going to take that as well. And then we're going to multiply back, and it has to equal each of these terms. So I got 3 of them I need to have inside that multiply to these 3 terms. So 4v times what is 28v squared, or v to the third? That's going to be 7v squared. And then 4v times what is 32v squared? That's just going to be 8v, because 4 times 8 is 32. And 4 times what gives you the 40? So that's going to be 10. Now check these. Make sure these left over in the parentheses do not have a GCF. If so, you might have picked the wrong number and there's something more you can take out. But 7, 8, and 10, there's no number that goes into all 3 except 1, so we're done here. All right, looking at here, is there anything we can take out? 6, 3, and 7? No, there's nothing we can take out there. Is there anything, any variable in common? Neither of them have all x's or all y's, so we can't take out a number or any variable. There's no GCF here, so we're going to call this prime. No GCF. Okay, lastly, we can, on number 8, we can see that, well, 15 and 25 easily have a factor of 5. Okay, and then look at the m's. Right? All of them have an m, so we can take out an m. And then look at the p. So it looks like they all have a p. We can take out a p. And then look at the last one, q. Looks like only 2 of them have a q, so we can't take out a q. So we're going to have 4 terms. I multiply back to the 4 terms in the original question. So 5mp times what gives you 15? That'll be 3, right, to give you 15. We have 1 m, we need 3, so we need 2 more m's. And we have 1 p, we need 2 p, so 1 more p. So this times this now equals this first term. And just repeat the same process for each of the other 3. So we'll get 5, right? We already have 1m, We only need one m, so we're done there. We have one p, we need two p's. So I need a p to make p squared. And there's a q here, so I'm going to need a q also. So it's just a repetitive process that you repeat. Here we go. We'll get 3q and 5, and we have MP, so that's it. And again, check here, make sure nothing else is a GCF and what's left over. Just make sure you got everything out the first time around. They should not have any in common. All right, so that's just finding the GCF, which is the first step of all these others. You always want to look and do what we just did to see if we can make these numbers a little smaller from the very beginning. So let's start this right here. All right, factor, is there GCF? Is there some number that goes into all of these? I can't find one, so we're going to go, let's see, 4 terms. So I'm going to go into factor by grouping, which means group the first 2 and the second 2. And since we can't find a GCF with all 4 of them, you're just finding a GCF with the first 2 and then a GCF with the second 2. So what goes into 12 and 6? We get 6. And they both have at least an x squared. Take that out. We'll get 2x minus 1. Now, in order for factor by grouping to work, the next one also has to end up with 2x minus 1. And you just need to figure out what goes here so it multiplies to 14x and to negative 7. And you'll end up with plus 7. All right, so one of my factors is going to be this, 2x minus 1. And the second factor is going to be those 2 GCFs, 6x squared plus 7. And the order here does not matter. It can be in either order. And you can always multiply these back and see if it equals the original question. If it does, you know you've done it right. So you can do a check here. All right, that's 12x to the third. Multiply these two. All right, that's 14x. Multiply these two. Well, that's negative x squared, 6x squared. And multiply these two and minus 7. So you can see how it equals the original. Even though the middle two are in a different order, it does not matter. It's still the same thing. Always do a check just to make sure. Number 10, look for that GCF. 2, 4, 6, and 12 all have a GCF of 2. So that must be done first. This is like the first 3 we just did here. 6, 7, and 8. Always have to look for that GCF first. And then that'll make the rest of the problem a lot easier. Right? Now, reminder that your answer is going to look like this. You're going to have that 2 in the very front of your answer. It has to be carried down. Okay. So we've got that 2 in front, and then we're going to have, well, what's the GCF of the first 2, and what's the GCF of the second 2? Same thing we just did in number 9. So a squared, a minus 2 is the leftovers, so this also must be a minus 2. And what do we have to put here to get negative 3a and 6? That's going to be a minus 3. Give us negative 3a and positive 6. So we got a squared minus 3, right? And then we got a minus 2. And this cannot be factored more because this is a 3. You cannot write this as a difference of 2 squares like we did back in number 3. Number 11 we're on here. Okay. So no GCF, 2 terms, and I see a bunch of squares plus a perfect square 25, which is a hint, probably a difference of squares. So 25m to the second can be rewritten as 5m times 5m, or 5m to the second. And n squared is just the same. Don't need to do anything there. So I know my 2 terms are going to be 5m and n. Okay, so we have 5m, n in both of them. Right? It's going to be the same whatever it is that's being squared. And then, of course, one is positive, one is negative. And you can even multiply this out and check it. And you'll see you get 5m squared, negative 5mn, positive 5mn, and then negative n squared. So it comes out to the original problem. All right, number 12, you can see some perfect squares here as well, 16 and 9, but we got this middle term, so it's not going to be a difference of two squares. And there is a little shortcut here if you're aware of it. If not, you can just look for the GCF. There's nothing that goes into 16, 24, and 9. Multiply 16 times 9. See what multiplies to, let's see here, 144. M squared adds to negative 24 m. It looks like we end up with negative 12m and negative 12m, same term. And that's not coincidence, by the way, that we have some perfect squares and then our two factors that we got here are the same. So let's go ahead and solve this out. So that's going to be the same, and I'm going to use my two middle terms here for the grouping. So instead of negative 24, I'm going to put in minus 12 and minus 12m. And just do the same thing that we did prior. Do some grouping. So what goes into these two? 4m. Right? This must also be 4m minus 3. And you can see this will be a minus 3 to make negative 12 and positive 9. And what happens here is that we get two terms that are the same. Okay. Now, this is not the right answer, is it? Did I take a GCF first? Yeah, so always look to make sure. Maybe you took a GCF at the beginning and you forgot to put it here. And yeah, we didn't take a GCF first, so yeah, this is actually the right answer. Always check to make sure we didn't forget that GCF. And you can always check by multiplying it back together. Well, that's 16m squared, and so on, negative 12, negative 12m, and then negative 3 times negative 3 gives you the positive 9, so you know you're good. Here we have some perfect squares. This is going to be 5x to the second, and this is going to be 4 squared, but the problem here is that it's not a difference. So because of that right there, not being subtraction, and there's no GCF here, 25 and 16 have no common factor, this is prime, does not factor anymore. Number 14, no GCF. So what two numbers multiply to 6x squared and add to negative 1? So we'll get a 3 and a 2x with the negative being on, let's see here. Looks like negative 3, does that work? That'll add to negative x squared here, or negative x, but doesn't necessarily multiply to 6x squared. So then you might try, well, maybe try like 5 and 1. Like what multiply does 5 and 1 work? So 5x and 1x, because those are factors of 6, but those cannot add to negative 1. So if you try everything and there's no way for it to work, then yeah, it must be prime. There's no GCF, so it has to be prime. Okay, number 15. No GCF. What multiplies to negative 12x squared and adds to 1x? This time I think we can get it. 3 and 4 multiply to 12. And to get positive 1, I need that to be negative. And now I'll multiply to negative 12. So we got x squared plus 4x minus 3x minus 12. Remember, these two replace the 1x with the 4 minus 3. And then we could do our grouping. And our answer will come out to x plus 4 and x minus 3. I'll let you fill in the work in the middle there. All right, we got 16. Any GCF for 7, 60, and 100? Probably not. Okay, so we got to figure out what multiplies to negative 700, a to the second, adds to 60. Okay, now, first thing you probably want to come up with is, well, what multiplies to 700? And don't think difficult, think easy first, like maybe 70 times 10. And then right away you say, oh yeah, 70 minus 10 is 60. Sometimes these big numbers you can think it's difficult, but really not so much. Yeah, 70 times 10 or negative 10 gives you negative 700. 70 minus 10 gives you 60. So same idea. We're going to replace the 60 here with 70 minus 10, a, and then do the grouping. Right, so what goes into those two? 7a with an a plus 10. The second part must be an a plus 10 as well for this to work. And this number, in order to multiply to negative 10a and negative 100, would be negative 10. We have 7a minus 10 and a plus 10. Okay, number 17. Any GCF here? 15, 12, and 3. And yes, there is. 3 goes into all of those. Make sure you take that out first. Right. Now our answer is definitely going to have that 3 in front. So I'm going to write that right now so I don't forget to leave that in the front of my answer. And then I can go through and say, well, what multiplies to, now we're just doing this trinomial only like it's its own new problem. So negative 5r to the second, and then adds to 4r. So it looks like our two terms would be, let's see, probably 5r and 1r with a negative on the 1. So 5 minus 1 is 4. 5 times negative 1 is negative 5. So we got 5r plus 5r minus r minus 1. Right, I just took these two, replaced the 4r, but the 5r squared and the negative 1 stayed the same. Right. You can do your grouping here. First term, we'll get r plus 1. This one is also r plus 1. To get this to work, we need a negative 1 to give us negative r and negative 1. So we got 5r minus 1 and r plus 1. With a 3 in front. Got to have that 3 there for it to be correct. Because if we multiply this back together, it has to equal this 15. Without that 3, we just have 5r and r, which does not multiply to 15r. Okay, just a few more to go. Always looking for GCFs. So we got 10, 48, and 32. So looks like 2 would work, right? So let's take out a 2. That's a 5n squared plus 24n plus 16. So a reminder, my answer is going to be 2 times whatever this factors to. So we can go through here and do the work. 16 times 5 like is 80. So what multiplies to 80n squared and adds a 24. So you might have to do a little bit of work here to figure out the two numbers. And you might try 8 and 10 at first, but 8 plus 10 is 18. And after a little while, you'll get 20 and 4. That multiplies to 80, adds a 24, and you can start to finish this. And GCF for the first two is 5n, left with the n plus 4. So this must also be n plus 4 In order to equal 4n plus 16, I need a positive 4. So we get 5n plus 4 and n plus 4. Okay. Lastly, there we go. We got a difference of squares here, no GCF, so this is going to be x squared squared, that gives you x to the fourth, minus 1 squared. All right, so we got our two squares, x squared and 1. So I know this is going to factor 2, x squared plus 1 and x squared minus 1. Now be careful, you're always checking to see if any of your answers factor more, and this time this does because this is also a difference of two squares. This is x squared minus 1 squared. So that is going to factor in the same way the first two did. X and 1, like I did here, x squared and 1. And I got x squared plus 1, x squared minus 1. Well, we can factor that again and get x plus 1 and x minus 1. And don't forget to bring this down here as well. And those don't factor any further, so I know that that is the final answer. Now make sure you saw how the speed I was going through on this. If this seemed very fast to you, that means you need to practice this several times over until you get the speed up. Okay. If you spent the time watching this video and just copying it down on the paper, that's not going to work on the test, right? You can't just copy it down on the test. You have to know how to do all of these by yourself with no help. So make sure you print out another one and you can do this whole process by yourself with no help without looking at the video at all or the answer key and still get 100%. It might take a few times, but that's how you'll get good at this and be able to do well on the test. Okay? So good luck and happy studying.